What is logical data in MATLAB? That's exactly what we're going to check out in this video. We're going to start by going up to the documentation search bar in the top right-hand corner of our environment and typing in fundamental data classes. Then we push enter, and the first entry in this search query is going to actually read fundamental MATLAB classes. That brings up this search documentation, fundamental MATLAB classes. I encourage you to read through this on your own. One of the deliverables of this course is I want to help you learn how to teach yourself MATLAB. So much of the functionality of MATLAB is actually included in the documentation. So if you get good at learning how to read the documentation and teaching yourself, you won't need a teacher to actually help you learn how to decode this information. With that said, it's not easy to read this documentation, and that's why we're doing this as a team. With that in mind, let's jump into the first paragraph here. Notice there are many different data types in MATLAB. These are called classes. So types of data are known as classes in MATLAB. In fact, this documentation is claiming that there are actually 16 fundamental data classes that MATLAB provides natively within its environment. Each of these classes is in the form of an array. Remember, MATLAB stands for Matrix Laboratory. One of the defining features of this programming language is that it is an array-based language. In other words, when we store variables using these different classes, the default mechanism is to store them as arrays rather than scalars. One kind of fun feature of this documentation, notice my search query read fundamental data classes. We found this documentation by clicking on the top search result from that query. And notice that each of the search terms is highlighted in a different color. So fundamental is in yellow, data is in blue, and classes is highlighted in green. That allows me to relate my search query to the actual documentation that I'm reading. Let's go down to a visual representation of these 16 fundamental classes. Notice that many of these are stored in matrices or arrays, and these can be either full or sparse. We've got something called a logical class, a string class, a character class. Then we have a group of numeric classes. In fact, we can count them. 1, 2, 3, 4 times 2 is 8. One more is 9, and one more is 10. In other words, MATLAB provides 10 different built-in data types to store numeric data. There's also something called a table, a cell, and a structure. One interesting note is if we count 1, 2, 3, 4, 5, 6, plus the 10 numeric data types, that's 16. So 16 fundamental classes for array-based data. And then there's one additional class, which is something called a function handle. And these are stored as 1-by-1 arrays, in other words, scalars. Don't trip on any of this discussion in this moment. We're going to get deep into many of the different data types as we move on in this course. The point of this video and this discussion is to focus on the first of these data types, which is known as a logical data class or logical data in MATLAB. Let's go ahead and find all documentation associated with the logical data class. To do this, I'm going to push Command F. That brings up this little search query, and this says find in page. Then I'm going to type the word logical inside because I want to see everywhere where this particular documentation refers to the word logical. Notice over here I have the scroll up and scroll down. When I push scroll down, MATLAB is going to automatically highlight the first instance of the word logical in the entire documentation. Let's go ahead and read that full sentence. We can build matrices and arrays of floating point and integer data, characters and strings, logical true and false values, and so on. So that sentence tells me that I can actually build an array of what they call logical true and false values. I wonder what that means. Let's read on. To do that, let's go ahead and go down to the next instance of the word logical. MATLAB automatically highlights. We can create two-dimensional double and logical matrices using one of two storage formats, full or sparse. For matrices with mostly zero-valued entries, we're going to use a sparse matrix. We see that a sparse matrix requires a fraction of the storage space required for an equivalent full matrix. Okay, so MATLAB is telling me that I can actually store logical matrices, and I can do it in one of two forms, full matrices or sparse matrices. That sentence tells me that sparse matrices require less storage space, but require that the entries of the matrix are mostly zero. We'll come back to that in later lessons. The point though is that I am learning now by reading this documentation that I can create something called a logical matrix. That doesn't quite seem logical, but we'll see what they mean by that. Let's go on to the next representation we're going to put down in this particular thing. These classes require different amounts of storage, the smallest being a logical value or an 8-bit integer which requires only 1 byte. What we just learned is that when we store logical values, it requires 8 bits or 1 byte. That is the least intense memory requirement out of all of my 16 classes. So we've learned a few things about logical variables. Number 1, they store something called true or false values. Number 2, we can store logical variables as arrays. In other words, we have something called logical matrices. Those can be full or sparse. Number 3, we require the least amount of storage space to store logical variables. For each single variable, it looks like it requires 8 bits. Let's keep reading. We'll push down in the search query to get me the next representation of the word logical. Notice that is in this table, which MATLAB describes as the following table describes the fundamental classes in more detail. There are 16 of them. One of those classes is logical. Notice that we can click on documentation, which is logical operations. If I right click on this and then say open in a new tab, MATLAB is going to create a new tab of that documentation. What's nice about this is I can put both of those documentations side by side. So I've got my logical operations documentation right next to my original. That's nice because I can scroll back and forth and compare the two. Notice then I can go click back on the single screen right there and it will get me back to the individual tabs as individual entries in the left menu here. So I can click between logical operations and fundamental data classes. We're not going to worry about logical operations right now. We're just kind of getting an overview of what logical data means. So notice that MATLAB is telling me that logical data is used in relational conditioning or to test the state of a variable. We're not sure what that means right now. When we move down from that first bullet point to the second, MATLAB is telling us that logical data is constrained to have one of two values, either true or false. We can click on each of those to learn more about it. This is also useful in array indexing, which is what MATLAB is saying here. And the two-dimensional arrays can be sparse. In other words, that's exactly what we saw in the description above. I don't know if you feel the same way I do, but often when I first read a piece of documentation, I'm a little bit confused of what it says. And this is exactly what I'm going to show you next, which is when we're reading documentation, we owe it to ourselves to slow down our processing and compare what we're reading to what we already know is true in MATLAB. Let's do that now. We remember from a previous video that variables in MATLAB we think about as having actually 3 different characteristics. The first of those is called a user-defined symbolic names. We've seen rules for defining variable names, and we've also seen some best practices on how to do that. The second feature of each variable is called an assigned value. We have just learned in this entry that a logical variable can have one of two values, either true or false. So this little bullet point right here says that when we're defining variables in MATLAB using the logical data class, the assigned value can be one of two things, either true or false. Moreover, up here when we were reaching that logical variables take the least amount of storage, what we saw is that each logical value requires 8 bits of storage or 1 byte. In other words, the specific storage location is going to point to an 8-bit string in memory, and the assigned value is going to be stored in 8 bits, in other words, in 1 byte. I'll stop parsing that documentation now and turn into teaching mode where I actually start to deliver some content that is not so easy to find in the documentation. The point of that little foray, though, is to show you that one of the best gifts we can give ourselves is the gift of reading deeply and thinking slowly about what MATLAB documentation has. In truth, I have taught myself almost everything that I need to know about MATLAB using MATLAB's online community, MATLAB's internal documentation, and online searches from other forums like Stack Exchange and bloggers who write specialized blog posts on MATLAB itself. If I can teach myself MATLAB using those resources, you can do the same thing for yourself, because anything I can do, you can do better. With that, I'm going to transition out of learning mode and into teaching mode. Specifically, I'm going to deliver some content to you. When thinking about the logical data class, I'm going to coach you to think about 4 different purposes. The first of those purposes is to perform logical operations. So logical data is used to perform logical operations. The second one is to perform something called relational operations, or to compare two pieces of data against each other. The third is to test the state of MATLAB variables and actually MATLAB entities. We'll see more about what that means later. And the fourth is to either address or find special entries in stored arrays. So 4 different purposes: perform logical operations, perform relational operations, test the state of MATLAB entities, and address arrays in special ways. Each individual item on this list has many subtleties, and we're going to actually do multiple videos for each of these so that we can explore some of the full functionality encapsulated in logical data. To start with, we're going to actually declare our first 2 logical variables, and we're going to do so using a function called logical. Specifically, if we type in help logical and go ahead and push enter, notice the logical function converts a numeric value to a logical value. So specifically, if I call logical of x, this converts an element of the array x into logicals, or logical tests. For more information on this, we can click on the documentation and read through it. However, I'm going to give you some simpler examples. We're going to start by declaring some variables. We'll call 1 equal to number 1. Then we're going to call 0 equal to the number 0. If I go over to my workspace, notice that I have 2 variables stored in memory. The variable 1, which is the numeric name of that, has the stored value 1. The variable 0, the numeric name, has the stored value 0. If I actually right-click and then go choose columns and then go down to class, if I expand and maximize, notice that these 2 variables are stored in the class called double. That's a numerical data class. Specifically, it requires 8 bytes. Remember, in our documentation, we saw that logical data is its own class in MATLAB, and it only requires 1 byte per variable. Let's go ahead and test this. Let's go ahead and set capital T equal to logical of the number 1. Now, all of a sudden, MATLAB reports back that T is stored as a logical variable, and its value is logical 1. Let's go back to the workspace. Notice T has value 1. It's a 1-by-1 array, but it only requires 1 byte, and it is not stored in the double class, it's stored in the logical class. Meaning that the assigned value of 1 for the variable 1 does not have the same interpretation as the signed value of 1 for the logical variable T. One of these is stored as a double, the other is stored as a logical. Let's go back and do a second logical declaration. So if capital T is logical 1, we might say that capital F is logical 0. So let's go ahead and write that in. Notice MATLAB returns back that F is stored as a logical variable and it has value 0. If I go back to the workspace, I see the exact same thing. Here I have the small image to represent logical variables. The name of that variable is F. The stored value is 0. This is a 1-by-1 array, and it only requires 1 byte because its stored value is done in a logical. One of the reasons that we thought about variables as having these 3 features, the user-defined name, the assigned value, and the specific storage location, is depending on which data class we use, the assigned value has different interpretations. Also, the storage location that we have depends on the amount of storage required for each variable. What we're seeing here is that 0 is not equal to 0. This is a strange concept in computer science that kind of defies the rules of mathematics. The 0 stored in the capital F variable is not the same 0 stored in the lowercase 0 variable because the data class used to store it is different. We're going to have so much more to say about this throughout this class. This is just small insights into a much larger theme, which is the data class we use to store variables very much impacts the way that we do calculations. With that, let's specifically pinpoint what we use logical variables to do. Logical variables are our way of turning mathematical true and false statements into actionable computations that we can run in MATLAB. The map that we use to do that is called a relationship between something known as a truth value and a corresponding logical value stored in MATLAB. Remember, every logical variable has either one of two values. One of them is called true. True is assigned a logical value of 1. The other value that logical variables can take is called false, and that has the value logical 0. The claim that we're making in this video is anytime we use logical data, that data will have one of two values, either 1 for things that we evaluate as quote unquote true, or 0 for things that we evaluate as quote unquote false. And the claim is we can use these type of evaluations to do multiple things. What can we do? Well, we can do one of 4 things. We can perform logical operations. So one of those we're going to see in a later video is called a not operation. So remember that T means true. Let's go ahead and try what not T means. Well, could you guess what it means not to be true? You got it. It means to be false. So we just did a logical operation on the variable T, and we got a corresponding output that when something is not true, it must be false or 0. Second operation that we could perform is to do relational operations. In other words, I can ask MATLAB, please check for me, is 7 equal to 8? The double equal sign says check the truth value of this statement. Notice that 7 equal 8 results in a logical output of 0. In other words, MATLAB is telling me what you just put in the computer is bullshit. This is false information. Let me report that using a logical variable. Remember, the third thing that we could do is test the state of MATLAB variables. So remember, we have this variable called T, which is stored using a logical data class and whose value is 1. We can use a test state function, which is called isA. So now I'm going to ask MATLAB, the variable T, is it a double? So is this stored using the double data class? MATLAB immediately returns information to me in the form of a logical variable. The value of that return is 0. So MATLAB has just told me the variable T is not stored as a double. This is a false result for my test. However, if I were to say, is T a logical variable, MATLAB would produce a 1 telling me T is stored with a logical variable. The last thing MATLAB allows us to do with logical variables is to address or find special entries in an array. Specifically, let's pretend that I defined a row vector that starts at 8, goes down by -1s, and goes down to 1. There's the row vector. Now, if I were to type x equal 6, I am effectively asking MATLAB, please find the values of x that are identically equal to 6. MATLAB is going to return a logical row vector where all the values of that vector test that individual relation. Notice in this situation, that logical vector says that the third entry of x has value 6, which is really incredible because if I now take the logical vector produced and put it as the input to my vector x, I can now pull off the exact value that I was looking for. Don't worry about any of these applications. We're actually going to do multiple videos on every single one of these purposes. The point of this is to start to highlight what logical variables are designed to do, which is these 4 purposes. Main takeaway: every logical variable can have one of two values. It's either going to be true, which is encoded as a logical value of 1, or false, which is encoded a logical value of 0. Those variables are used for one of 4 purposes, either to perform logical operations, relational operations, test the state of a variable, or find and address special entries of an array. Could you guess what we're going to do in the next set of videos? Ding, 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 ding. We're going to look at how to perform logical operations using logical variables. I can't wait to do just that. Thank you so much for your attention. You're always welcome to leave comments and questions in the comment section below, and I'll see you in the next video.